One paper will be a theory paper. One paper will be a MCQ paper. And the other paper is your alternate to practical. So we started with paper 4. Okay. I'm just doing topical, the topics we have already covered. Okay. So let's start with the light first. Okay, let's start with the waves. Ibrahim, one difference between a longitudinal wave and a transfer wave is that a longitudinal wave consists of compression and rarefaction. Explain the terms compression and rarefaction using ideas about the particles. Who will tell me that? Ibrahim, Yumna, or Armina? Yes. Anyone? Ibrahim? Yes, Ibrahim. Can you tell me?
Um, so compression is like when particles are very close to each other,
Yes,
and
that's it. So basically, compression is the region in the wave, in a longitudinal wave, where particle of the mediums are very close to each other. Armina, what about rarefaction? Yes, Armina. Or Yamna? Ibrahim? Hello? Anyone? Yes, Ibrahim? Or Yamna, whoever. Anyone wants to answer?
I think in rarefaction the medium it's like spread out
So you can
or
say
the
the
particles are far away.
of particles are a region in the wave in which particles of the medium are far away from each other. Okay. That's it. So write it down. Then they say describe one other way in which longitudinal wave motion differs from the transfer wave motion. So what is the difference and how? Yes, how do you define transfer waves and longitudinal wave motion or their contrast? Who will tell me that? Ibrahim?
sir, the wave particles are parallel in longitudinal, and in transverse they go the other direction.
But you have to explain that what you have just said. You can't write like this. You say in longitudinal wave, the particle of the medium travels parallel to the direction of the motion of the wave. In transfer waves, the particle of the medium travels perpendicular to the direction of the motion of a wave. So in longitudinal, the particle travels parallel to the motion of the wave. In transfer waves, the particle of the medium travels perpendicular to the direction of the motion of the wave. Anyone have any question in this? Okay. Copy that quickly and then we'll proceed. Okay, guys, everybody wrote it? All right, let's move on. Okay, now next. Who will solve that? A sound wave of frequency 0.120 kilohertz travel through a rock at a speed of 3,500 meter per second. Calculate the wavelength. Armina, which formula shall we use to find out the wavelength? Ibrahim? It will be
Sir,
V.
lambda over something.
It's V is equal to frequency lambda. That is a formula.
Yeah, yeah.
Now lambda will be equal to V upon F. So velocity is how much? 3,500. And the frequency is, you have to convert it into hertz. So it will be 0.120 into 10 raised to power 3. So what is the value coming up?
Sir, 29.16.
29.16 what? Unit? Armina beta, what is the unit for this? Unit is meters, right?
Yes, sir.
Now, next question is very interesting. They say wave travel from rock into air. State and explain whether the wave will be audible to the healthy human ear. Do you remember what is the range a human ear can able to hear? That is 20
Sir,
hertz. Yeah. What is it?
20,000.
20 hertz to 20,000 hertz. So you tell me, is it audible? 0.120 into 10 to the power 3 means 120 hertz. Is it audible?
Yes, sir.
It is audible. So a statement will be, you will write the way, you just write here, a statement will be, the frequency of that wave which is traveling here, the frequency is 120 hertz. An explanation will be that it will be audible by the human ear. In the statement, you will write, it will be audible by the human ear. An explanation will be that audible range for the human ear will be 20 hertz to 20,000 hertz. Statement will be that it will be audible by the human ear. Explanation will be that 20 to 20,000 hertz, this particular wave, or you can say range of wave, can be audible by the human ear. Copy that and then we'll proceed further. Yes, Safiullah, how are you? Assalamu alaikum.
Walaikum salam. I'm good. How are you?
Alhamdulillah. Safiullah, we are doing a past paper today. That is 2019 October November paper. We have done one question, but anyway, you will get that, in the recording. But we are continuing doing it. So inshallah, you will like it. Now, what my plan is that from now on we got 4 classes, right? So out of 4 classes, 1 or 2 classes we will especially assign for the past paper practice, and rest we will do the things which we are doing. All right. Yes, everyone write it. I hope everyone wrote it. Okay. So let's move on. Now, this is very interesting question. If it is the one I am looking for, wait a minute. Okay. All right. This is the one. Now, how to start with this question? They say, shows an empty container and an observer eye. There is a small coin at the position O. The observer and the coin stay in the same position and container is filled with water. The observer can now see the coin. Explain why the coin can be seen by the observer. Observer and the coin stay in the same position and container is filled with water. The observer can now see the coin. Now, why actually observer will be able to see the coin? Okay. This is for 2 marks. Who will tell me this?
Sir, because light is refracted in water
Yes.
and it would be seen further away from its original position,
Further
from above
away,
the water,
further away or towards the normal.
towards the normal.
So it's not further away, closer, right? Let's see the answer
Okay.
scheme here. What actually they wanted to say here. Let's check the answer here. Your answer is right. I think so. Explanation is right, but let's see. They say that light from water, light, air, light from coin bends, change the direction, and it is refracted. So you can say bends away from the normal or angle of incidence is smaller than angle of refraction. The one you are saying is absolutely right. Light from water or light to air. So basically what happened is, where is it? Because he's staying here. So when light comes from denser to rarer medium in the air, it bends away from the normal. And when it bends away from the normal, it will be seen. So you just need to write few lines here that because of refraction of light from water to air, or you can say from denser medium to rarer medium, light bends away from the normal or changes its position. Because of that, observer will be able to see the coin. So you have to mention two things in this. One is the refraction and one is light bends away from the normal when goes from denser to rarer medium. Denser means water, rare means air. Next, state the name of the wave process which occurs as the light passes from water into air. Yes, what is the name of it? Yes. What is the name of a process? Who will tell me this? Ibrahim, any guesses? It's a refraction. Light goes from one medium to another medium. So answer will be just refraction. Next question is explain why the image of a coin is a virtual image. This is for 1 marks. Why the image is a virtual image? Yes, students. Yes, why the image is virtual? Who will tell me that? Ibrahim, Safiullah, Yamna, Armina, anyone? Yes, anyone?
Sir,
Why the
because there is no image formed at the bottom of the container.
Yeah, actually rays do not meet at image, or you can say only appear to come from the image, do not originate from the image, cannot be seen on the screen. So now remember two, three things here. When you say image is a virtual image, first of all, remember that that image cannot be seen on the screen. That is the first point. A virtual image, I have told you previously, cannot be shown or cannot be taken it on the screen. That can be the answer. Or you can say light rays are not actually met where this image is formed. Because we know that we have done in light that light image seem to reach to a point where the image is formed if it's a virtual image. And we showed it with the dotted line, right? So actually light ray or actually image is not formed, but it seemed to come from a point. So that's why it's a virtual image, because light ray is not actually intersecting. Secondly, or third thing is that image which is formed here will not be achieved on the screen. So 2 points. Next question. State the speed of light in air. Now this is easy. The value, everyone knows it. What is that value? Yes, what is it?
3.0 multiplied by 10 raised to the power of 8.
Yes, meter per second. Absolutely right. Very good, Armina. No, answer me, man. You're not answering me, guys. Only Armina or sometime Ibrahim, I can hear the voice of. Yumna and Safiullah are totally blank. Please answer. Okay, next question. They are saying refractive index of water is 1.3. Calculate the speed of light in water. Which formula do you apply here to find out the speed of light in water? Ibrahim, what formula shall I apply here?
Sine I over sine R.
But there is no I, there is no R given, only the speeds are given. Safiullah, do you remember any formula in terms of speed of light or speed of light in something, speed of light in some medium or speed of light in air, something like that?
No, sir.
Very good. And what about you, Armina? Do you remember any formula?
No, sir.
You forgot, guys. Please go through. The speed of light in air divided by speed of light in medium. That is what the formula is. And the medium in that case is air. Sorry, speed of light in air means speed of light is air, that is fine. And the second one is speed of light in water. Denominator will always be the one you have to find out the speed of. So speed of light in air divided by speed of light in medium. Here this medium is water. And that is given as 1.3. Now speed of light in air is 10 raised to power 8. Speed in water. So SW will be equal to 3 into 10 raised to power 8 divided by 1.3. Can anybody tell me what is the speed of light in water by using this formula? 3 into 10 raised to power 8 divided by 1.3. Okay, yes.
That's a big value.
Yeah. You know the easiest way is divide 3 by 1.3. What is the value coming up?
That's a big value.
No, no. Keep 10 raised to power 8 itself. 3 divided by 1.3 is how much?
It's giving 230769,230.8.
Press E and G button in your calculator. It will give you in the form of 10 raised to power. Press E and G button. In your calculator, there is a button E and G. It will give you
Yes,
answer.
sir. It gave 270.7692,308 multiplied by 10 to the raised power 6.
Good. Now another very important thing. This is meter per second. Now remember that that particular value which is given to you is not in standard notation as far as maths is concerned. The standard notation is that that decimal should be right after the first number. So if you move this decimal place 2 figures back, the 10 value will be increased. So the value becomes 2.30 into 10 raised to power 8. This is the standard notation. So if the question say you better write always in the standard notation, this is called a standard notation. If you get the answer like this, if you move back your decimal, the 10 raised to the power will increase always. Okay. So guys, everyone write it. Shall we move on? So this question is sorted. Now this is magnetism, which we are doing at the moment, but I'm not actually, for the time being, not doing this one. I'm interested in this. Just check it out. First copy that and then we will be doing this. This is your electricity. Read the question and tell me, will you be able to do this? Okay, anyone? Calculate the resistance of, sorry, a wire of length this in cross section area this has a resistance of 0.14 ohms. Calculate the resistance of another wire of the same material of length 3.0 meters and cross sectional area 0.90 millimeters square. How to do this? Which formula will you use here? Yes, guys, anyone? Any ideas which formula shall we use here? Everyone copied it? Say something, guys. You're not talking even. Just be quiet, everyone. Did you copy this?
Yes, I
Ibrahim.
copied it.
Okay. Ibrahim, what about you?
Sir, is it R is equal to IV?
But there is no I and V. It's all lengths.
So is it R1? So is it
No.
R1, R2?
If you remember that, we have done one formula that is R is equal to rho L upon A. Do you remember that formula? Remember or not remember?
Sir, I remember writing this down with you, but I don't know what it is.
It means that resistance is directly proportional to length, but resistance is inversely proportional to the cross-sectional area. And we have drawn this, we have derived this formula. R is equal to rho L upon A, where this sign means resistivity. So because the material are same, this resistivity constant will be same. Okay. So now what you need to do is, you have to put the values to find out this resistivity, because for the same material, the resistivity will be remain the same. Okay. So let's read it. The length is given as 2 meters. And
Sir, what do the L and the A represent?
L means length of the wire and A means the cross-sectional area of the wire.
Okay.
Okay. Now L is given as 2 meters. Cross-sectional area is represented as 0.40 millimeters square. And the resistance in that case will be given as 0.14. Each and everything is given. We can very easily find out this rho. But the problem here is, we either convert this length into millimeter or either we convert this millimeter square into meter square. What do you want to do? Meter into millimeter or millimeter into meter? Yes, students.
Meter into millimeter.
We can do meters into millimeter as well, but remember that the unit should always be SI. So you better change millimeter into meter. Now, a very important thing. 1 meter is equal to 1000 millimeter. So 1 millimeter is equal to 1 upon 1000 meters. But this is a square, right? So to convert this area into meters, you have to multiply by the number 2 times. 1 by 1000 multiply by 1 by 1000. If it's volume, then you have to multiply by 3 times because it's area. So you have to multiply it by 2 times. Understand? Can you tell me the answer for this, please? It will be 0.40 divided by 10 raised to the power 6. So when you bring it up, it will be 0.40 into 10 raised to power minus 6. Okay. Now, I told you if you move the decimal backward, the 10 raised to power increases. Now, if you move the decimal forward, the backward power reduces because you are increasing the number technically. So, move one decimal place, so it will be 4 into 10 raised to power minus 7. So, your resistance will be, not resistance, your area will be 4 into 10 raised to power minus 7 meter square. Now find out the rho value first. So rho value will be equal to resistance is given as 0.14 multiply by 4 into 10 raised to power minus 7 divided by the length, and length is given as 2. Can you tell me what is the resistivity value, please? 2 on the 2, 2 to the 4. So 0.14 to multiply by 2 is how much? 0.28 into 10 raised to power minus 7. The unit is ohm meter for this. If you want to put it in a standard format, if you move back here, the decimal value will increase. I mean, the 10 value increases, positive one. And if you move from left to right, the negative value increases. So it will be 2.8 into 10 raised to power minus 8 ohm meter. This is your resistivity constant. Guys, any problem in this?
No, sir.
Okay. Okay. Now they are asking you to find out the resistance of a second wire. Now this value is constant. I mean, this value is there. So basically, what happened? R is equal to rho L upon A. Rho is 2.8 into 10 raised to the minus 8. Length is given as 3, and the cross-sectional area is given as in millimeter once again. You have to convert this millimeter into meter again. So you have to multiply 0.9 multiply by 1 by 1000 multiply by 1 by 1000. So what is the value coming up for this? 0.9 into 10 raised to the power minus 6. Now again, when you move the decimal on the right hand side, this negative value will further increase negatively. But if you move the decimal value on the left hand side, the positive value will increase. So it will be positive 1 added, but on the right hand side, the negative 1 added. So 9 into 10 raised to power minus 7. So you will place here 9 into 10 raised to power negative 7. Now very simple few calculation. I mean, some calculations is very easy to, do that. 2.8 into 10 raised to power minus 8 into 3 divided by 9. And when you bring this 10 raised to power minus 7 in the numerator, it will become a positive value. Now this one will be 2.8 minus 8 plus 7 will be negative 1 into 3 divided by 9. Can you tell me the answer for this? 2.8 into 10 raised to power minus 1 multiply by 3 divided by 9. 3 1 the 3 and 3 3 the 9. 2.8 into 10 raised to power minus 1 divided by 3 is how much? It's 0.93 into 10 raised to power minus 1, or in other words, it will be 0.093 meters. So sorry, ohms. This is your answer. Students, any?
Sir,
Yeah, please.
sir, I got a different answer. Can you repeat how you did the calculation?
Okay, let's do it again. I will rub it again and let's do it once again so that you understand. Let me just rub that. I will systematically write it so that you understand. Okay. Now check this out. First of all, when the length, area, and these kind of things are given to you and they are asking you the resistance value, remember that they are asking you to use that formula. What is that formula? R is equal to, where is it? R is equal to rho L upon A. This is the formula they want you to use, where this rho means resistivity. It is called resistivity constant. Now remember that resistivity constant will be constant for each material. And they already write it that materials are same. So let's find out the first one. The length of the first wire is given as 2 meters. The area is given as 0.4 millimeter square. And the resistance is given as 0.14 ohms. Now, only thing which is not given is rho. So let's find out resistivity constant. First thing first, you need to convert this area into meter square. So how to do this? 0.4 into 1 upon 1000 multiply by 1 upon 1000. Why 1000? Because I have already told you 1 meter is equal to 1000 millimeter. And 1 millimeter is equal to 1 upon 1000 meters. When it's the area, you have to multiply 2 times. The value comes up is equal to 0.4 into 10 raised to power minus 6 meter square. You want to keep it in this form or you want to take it in a standard form, up to you. I'm leaving it so that the thing's going to be easy for you. Now we need to find the resistivity constant. So resistivity constant will be equal to rho is equal to R into A divided by L. I just manipulated the value. R value is 0.14 multiply by area, which is 0.4 into 10 raised to power minus 6 and divided by length is given as 2. Can you tell me the answer for this, please, everyone? Keep 10 raised to power minus 6 as it is, multiply 0.14 to 0.4 and divided by 2. What is the value coming up? It's coming 0.02, sorry, 0.028 into 10 raised to the power minus 6. Now, what is the unit for that?
Sir, I'm getting 2.8 in 10 to the power minus 8.
Yeah. So, the only thing is you move it 2 decimal places. I've already told you if you move it on the right hand side, minus 8. Yeah, minus 8 because you move it on the right hand side. If you move it on the backward side, on the left hand side, the power will be further reduced because it's a negative one. So plus power will be added. Absolutely right. So unit will be ohm meter. This is the unit of resistivity. Now, resistivity will not change for anything. So now you can find out the resistance for the second wire. So R value will be equal to resistivity, which is 0.028 into 10 raised to power minus 6. Length is given as 3 divided by, now area is given 0.9. For this one, you have to do that. So let's write it here. 0.9 multiplied by 10 raised to power minus 6. This minus 6 and this minus 6 gone. The values are coming as 0.028 multiplied by 3 divided by 0.9. What is the value coming up?
Sir, 0.93.
0.09.
0.093.
So the resistance value is 0.093 ohms. Everybody understood this?
Yes, sir.
So when the areas and all the things are given to you, you have to use that value. I mean, you have to use that. Safiullah, any problem in this?
No, sir.
Good. Now this is no more in our syllabus, the logic gates in physics. So let's move on. It's not in our course anymore. Now this is called electric field. We will talk about this in a minute. How to solve this? Part C. When a fully charged, a 1.2 rechargeable battery can deliver a current of 210 milliamps for 10 hours. Calculate the charge that can be delivered fully. Anyone remember when we started it, I have told you a definition of a current. What is the definition of a current? Safiullah, what is the basic definition of a current? Very basic.
Rate of flow of charge.
So rate of flow of charge means I divided by Q upon T. Am I right? So Q is equal to IT. I is a current which is 210. This is called milli. Milli means 10 raised to the power minus 3. So 210 into 10 raised to minus 3. And what shall I put? 10 hours it's written. So what shall I put here? Armina, what to put here? 10? Or I have to convert it into seconds? Always remember, in this formula, you have to convert it into seconds. So how to do this? 10 hours can be converted into minutes first by multiplying it by 60. And then minutes will further multiply with 60 to convert it into seconds. So what is the answer? 210 multiplied by 10 raised to the power minus 3 multiplied by 3600, and that's 0. If you do calculation, what is the value coming up?
7560.
7560. And what is the unit for that? Coulombs. Let's check this out. What is the answer? And I believe this is the right answer. Let's see. Yeah, check this out. 0.093 was the answer, first one. And the next one is this. Very good. Yeah, 7600. They rounded off to this. They give you the rounded value. But we have to write the right answer always. Students, any problem in understanding these questions? Anyone? Hello?
No, sir.
Ibrahim? Safiullah? Yamna?
No, sir.
No.
No, sir.
Good. Let's move on then. Calculate the energy stored in a battery when full. How to find the energy, beta? Energy. What is the formula for the energy?
Sir, E is equals to IR.
V is equal to IR. I heard it. E is equal to IR. Which formula is it? E is equal to PT.
E is equal.
E is
Oh.
equal to PT. You have to find power. What is power? Rate of change of energy. Again, you reach to the point where actually, in case of that, if you remember, energy, right? Now, energy is equal to, you can use that formula, but there is no need for this. Power is equal to, if you remember, there is another formula for power. Power is equal to VI. So what is the voltage? voltage is equal to 1.2 volts. And current is equal to 210 milliamps. It means 1.2 into 210 into 10 raised to the power minus 3. Can anybody tell me what is the power value coming up? Yes, how much?
0.252.
0.252. And what is the unit for that? Watts. But we need energy, right? So energy is equal to PT. So 0.252 multiplied by time. Now time is given in hours, so you have to convert it into seconds. 10 multiplied by 60 multiplied by 60. So what is the value coming up for this? $36,000. What is the value?
9072.
9072, and unit is joules. Now, guys, I am giving you some formula for the electricity. Please go through them. Power formula is equal to VI. Another formula is equal to I square R. Another formula is equal to V square upon R. Another power formula in terms of electricity is P is equal to, or you can say E is equal to PT. Right? Then you have V is equal to IR. These are all the formulas which will be used. 1, 2, 3, 4, and 5. And then one more formula. I is equal to Q upon T. 1, 2, 3, 4, 5, and 6. No any other formula will be used other than that. These are the only formulas which will be used in this chapter. Armina, what is another unit of energy which they didn't even ask, but there is a unit of energy as well. This is called commercial unit of energy. If you remember, that unit is called as kilowatt hour. And how do we convert it? First, you convert power into kilowatt, and then you multiply time in hours with that power. It will give you energy. We will do 1 or 2 questions related to that, inshallah, in the next class. All right,
Sir,
students. Yeah.
after E is equal to
E is equal
sir,
to
after E is
PT.
equal to PT,
PT.
yeah, what do you do after that? Can you explain again?
No, I didn't do an. I mean, E is equal to PT. You mean in the question or in the formulas you are asking? I just put the value. Check it out.
Like under the formula is why did you write more values?
No, I didn't write. This is the formula I've written only. These are the list of formulas. See? E is
No,
equal
sir,
to PT.
on the right side. On the right side.
Here,
Yes. It's like
see, the formula is E is equal to PT, right? P is
yeah.
this 0.252 and time is given as how much? 10 hours. So
Uh,
I
okay.
converted 10 hours into seconds. How did I do this? 10 multiplied by 60 converted into minutes. And then I again multiplied 60 to convert it in seconds.
Okay.
So this is what the energy is. 9072 joules.
Okay.
All right. So student, we will finish our class at this point. Inshallah, we will continue from here and slowly but surely, we will move on the magnetism as well. All right. So take care and bye everyone. Allah Hafiz.